Hi, everyone. Welcome back to part 2 of the R workflow workshops on introduction to R packages. So if I'll put the website in here. So website's in the chat, but it's also right up here. That's what's been going out on the emails. If you scroll down, you'll see the links to the material. And if you have missed anything or you want to rewatch the video, I post the video for each session on the website. Usually it's 2-3 days later. Depends when I get the copy. So today I'm going to be building on what I talked about last week, but if you missed last week, I think still today is going to be fairly standalone. Okay, so another logistic here. As usual, the chat is kind of, I'll be following it and to follow, questions. But please, everyone, feel free to jump in and help each other out, answer questions if you know them, add comments, whatever you want. It's kind of your space for peer help. So, here we go. So there's a lot of different things, I could cover, going a little more detail into packages. And what I've decided to do today is focus a bit more on the aspects of sharing your package and using your package for communicating, not just for the code, but like communicating about your functions, either to other people, but obviously to your future self also, because I don't know if you're like me, you may forget fairly quickly how to use your functions. Even from last week, and I was jumping on and going through this material, I was like, oh, wait a second, how was I supposed to use that function, that little function I created? But fortunately, I'd made a help file. So I just did question mark and got there. Okay, so the material for today is I'm going to show you how to create print and plot functions for your objects in your package. This is something a lot of people don't know about, but or don't use, but it's super, super handy as you'll see. We'll talk a little bit more about our oxygen documentation. I'll review that one more time because it's going to be really important for the next step that I'm going to get to. And then I'm going to shift into giving you an introduction to PackageDown. PackageDown makes it really easy to make an HTML version of your documentation. And doing that is really going to increase your ability to share your package and make it super easy for people or your future self to understand your package. Then I'll talk a little bit about sharing, ways you can share, and then we'll share the little test package on GitHub. Hopefully I'm going to get to this part about checking the package. We'll see how fast I go. Okay, so let's hop in and talk about creating print and plot methods for your object. So let's see, how would I do this? Okay, we're going to start here. I'm going to give you a little background, and then we'll hop in and do it. So R is object oriented, and that means that if you do the command class parentheses and the name of an object, let me just show you what I mean here. Let's go ahead, and I'm going to open up that package we are working on. And there's a few ways I could do that in RStudio if I might have it over over here, if I click on that, you know, I might see that in my project list here. I happen to see that in my project list. I could click that, but I'm going to show you another way in case, like, for some reason you don't see that in your project list and you know you created a project. Another way to do it is to go to your the folder where you created that project. So this one's test package. You can see I've got a lot here. I keep everything organized by having anything that I'm going to put on GitHub. It's all in this this folder, so I can always find it. So if I click on that, you're going to see a file here. Mine's here, test package.rproj. That's the file that is identifying this as an RStudio project. If I double click that, it's going to open that up in RStudio. So that's another way to open up an RStudio project. We can tell I'm in the project because I see test package over here, this nice little blue cube here. Okay, so now I'm here in this, in the project. So if I said A gets 1, did that. So A is now a thing. You know, it's an object. Object is just the lingo that we use here. And if I said class A, you see it has a class, and that class is numeric. If I did A gets data frame, so now if you look at that, A is something. What is A? What does R think A is? So if I do it at class A, it says it's a data frame. So everything that you work with in R is going to have a class attribute. It's just a feature of it. You don't notice this when you're working with it, but the fact that everything has a class means that you can create what are called methods for classes. So if I type A, how did R know to print it out that way? So the reason it knows that is that there's actually the R developers wrote a function that says what to do when so if I type something at the command line, what's happening, the actual function that's being run is called print. So you see it's doing that. So in the base level, they've created a print function. And so when it sees that object typed at the command line, it's like, hey, how do I deal with this? Oh, I need to look for a print function. And then I'll know what to do. I don't know if there's a plot function for A. Probably not. We'll see what happens. Oh, okay. It did. It had some kind of default behavior. Yeah, but you see it did something. It figured out, hey, I've got a data frame. Okay, I have an idea of how I'm going to plot this. So the nice thing about that is we can do the same thing for our objects. And so like if you create create something, like you have a function that outputs something and you always want to plot it a certain way, rather than like remembering the script or remembering, maybe you want to print out a summary of it each time, then rather than trying to remember that, you just create a method, a print or a plot method. So let's go ahead and do that. So here we go. So the first thing that we have to do is we have to assign an class to our thing. So last week I wrote this function called little forecast, and it takes some data. It uses the forecast package to fit a README model to that, and it creates a forecast. So let's see what this does. I'm going to go here. Now, how do I use this function? Well, fortunately, I didn't have to store that bit of information in my head because I'm really bad at that. I wrote, oh, well, it would be helpful if I loaded it. Library. Actually, I'm going to install. I could have said library, but I'm going to rebuild it because I was doing some things while I was practicing today. So I want to make sure I have the right version here. So now I can do a little forecast. And fortunately, I wrote down here some little code to run this, so I don't have to remember how to run this little function. So there we go. So this is what this does. This is what this code here does. It fits this little model, and then it makes this little forecast, and then it uses ggplot to plot that. Okay, so that's nice. So now we can make a method for, let's do, I think I'm doing, showing you a little print method. Yeah, we'll make a little print method for this. First thing we have to do is assign a class and then return something from this function. So this is what we're doing here. We're saying that we're adding a class to this, and I've just made up something called foo. And I'm going to add that class to the existing class. So let's go ahead and do this. So why didn't I just say, hey, let's just make the class of this. So I'm going to return the fit here. I'm not going to return the forecast. I want to return the fit. Let's say I want to be able to do something with that fit later. So why didn't I just say, hey, set the class of this fit to foo? The problem with that is if I did that, I would lose all the class information that's coming from this. So all the functions and all the methods that the forecast folks have written to do things with this fit object are going to be overwritten. I mean, they're going to disappear because I've just gotten rid of that class information. So generally speaking, you're going to add your extra class on. So that's how we do it. So you can have lots of different, so some objects will have many different classes to them. The first one that you see is the first place it looks, and then for methods, and then the second one is the next place it looks, etc. So for example, like if you say you were returning a matrix and it was a special matrix, you could write a print function. So when you type the name of that matrix, it's going to print out something special, but it still knows that it's a matrix, and all the things that matrices are able to do are still going to work fine. So just be careful about that when you're changing classes or adding. In this case, we're just going to add a class. So we're going to return that. Okay, great. So now we have this class, and we're going to save that. And we're going to create a print method for this. It's really simple to do. Here we go. I'm just going to copy this code. Go here. So this is my R-Oxygen code. So from last time, the first line is the title, the neck, and then a blank line, and then the description, and then blank line, and any arguments in your function. You can see this has two arguments, X, which is the object, and then dot dot. This is the standard format that print objects will, print methods will have. And you notice here that it's just print and then dot the name of the class. And that's it in R to define a print method. All you do is dot and the name of the class. And there's some ways, what is it? Oh, can I remember off the top of my head? Is it methods? Oh. Methods LM, is that what it is? No, it's not. Okay. Oh, no, yep. No, that's not it. Methods print, is that it? It's probably closer. Yeah, okay. So that method shows me all the print methods that are out there, and you can see it's obviously very common for people to write print methods. So there's a print method for terms, for table, for all kinds of things. So anytime you have an object that has class, you know, what's the first one here? Class ACF, it's going to use that print method for ACF. Ariana asked, yes, when there are conflicting methods, it uses the one in front. Yes, that's right. It's going to use the first one. Okay, so that's it. That's how I created it. And then I tell it what I want it to do. There is one special bit to the R-Oxygen code that is really important. Whenever you are defining a method, you need to do this @ method. And then you're going to say what kind of method. It's a print method. And then the class. So it's just print and then foo. Okay, I think that's it. I want to save it. It literally doesn't matter the name that you give it, but I will always save mine like this. So the print, what it is, and then the class, and that way I can find all my print methods. Save. So let's install and restart, see what happens. Okay, let's scroll back up here and look at what it did. Okay, updated document, loading that, writing that. Okay, that all looks good. Let's take a peek at what it did to that namespace. Ah, interesting. Look here. Now we've got this thing called S3 method print comma foo. So for our package, it specifies that, hey, we've got this method here for this object class of foo. So that's great. I am showing what are called S3 methods. They're really flexible, but and they're really easy to write, just like I showed here. But there are other types of classes you can define in R if you need a lot more, like error checking for the object to make sure it has all the right forms and everything there. But these S3 methods are quite easy to use in common. So now let's see what happens when we do, let's go back to the help. Gonna run. No, we don't need that. We already defined that. Let's get this. And now remember that I'm having this function return something. So I'm just going to say AAA gets this. Okay, so what's going on here? Let's look back here, see what's happening here. So I changed it so that I'm saying return fit. So it's returning this README fit. That's what's being returned here. And I'm going to put what it's returning into AAA. Here we go. And now when I type AAA, well, let's do class. Let's see what class this is. Ah, there we go. So you can see it's got those other classes on it. So all the methods associated with these things are going to still work, but the print method I defined for foo, so it's going to use that, the one that I just defined. So if I do AAA, it says hello there. Obviously not that useful for this, but you can make it whatever you want it to say. So for example, for me, like I am often like my objects that are coming out are like output from some big model. And I don't want to be digging through all the metadata for my object. So like in my metadata for my object, I'm going to have like what the parameters were, what the site was, all kinds of like information about the simulation, which set of data I used, all that. And it would just be a waste of time for me. Like every time I was curious about one of my simulation outputs, to have to dig through all that information, because I always want the same thing. So I can just write a little print method, and every time I type the name of that simulation object, the output from my model, it just prints the summary information that I want to see. So yes, it takes you a little time to write this print method, but it will save you a lot of time. Can you change the answer it gave to class AAA? Yeah, let's look here and see what's going on. So AAA is what's coming out of little forecast. So right here, so it says return fit. What is fit? Fit is this line right here. So there. But right above there, I changed the class of fit. And what I did was I added foo, which is the name of my little object class, new object class. I added that on to whatever the other object classes wore for fit. And you can see what those other ones wore: forecast ARIMA, ARIMA, ARIMA. So you can see that, or maybe you can guess what forecast does. So forecast does the same thing. They're using some base functions that are creating these ARIMA objects in base R, and those objects have these classes on them. First one is this, and the next one's this, and then forecast adds its own object type on top of that. But it wants to make it very clear that this is an object coming from the forecast package. And so it names its objects forecast underbar ARIMA. This is a convention that you're going to see fairly often, where a package writer names their objects with the package name and then gives it a name. That way you keep track of which package is defining that object. So in my packages, like I have a Mars package, all my objects that I'm defining for my package have Mars, and then they have the name of the object. Okay, let's keep moving along here. I show an example of a plot method. I'm not going to do that example. It's same thing, same idea, exact same idea, except the method is method plot and then class name. Okay, so now I want to talk next a bit about like sharing. Well, sharing. I'm going to talk about the PackageDown package and creating an HTML version of your package documentation. Before I do that, I'm going to review our Oxygen documentation. If you're doing our packages, you should use our Oxygen 2. That is what everyone uses. It's standard. Yeah, just learn it. Once you get started, it's quite intuitive and simple. Just got to get past a short, steep learning curve right at the beginning. Setup is you're just going to install our Oxygen 2. And as I showed last week, there's one setting you need to do within RStudio. So I'm in test package. RStudio knows it's a package because it sees this description file. You can look at that. It's got some basic info. That's what RStudio uses to detect that this is a package. Now, if I want to use our Oxygen 2, I need to go into Tools, Project Options, Build Tools, and then I need to check this box here. If you don't see this box, it means you don't have our Oxygen 2 installed yet. So do that Install Packages our Oxygen 2. So you want to make sure that's checked. And then by default, it's not going to be checked here. And I always check that just because when I'm like working on a package, every time I do install and restart, that's how I want to rebuild that documentation and then be able to check the documentation. So check that. And that's it. And then you're good to go. And you can tell that it's building because you're going to see when you hit install and restart, you're going to see this code come up, which is telling you it's using our Oxygen to, it's rebuilding the documentation for you. Okay, so that's how we get it set up. Once we do that, then the R oxygen header is right here, and this is how we're going to document our function. So the nice thing here is our documentation for a function is not a separate file. It's kept right there with our function, so they don't get out of date. It has a very standard format. The first line is title. You don't need at title, but if that helps you remember what that is, then use it. The next is we have a empty line, and then we have description. You don't need at description, but again, you can add it if it helps you remember what it's for. The next one is details. If you want them, put more details. Next, you're going to define your function arguments. So these are the things that are being passed into your function. So you just do at param and then the name of it, whatever description you want. At examples, this is not required. This param is required. Example's not required, but I try always to put an example. Maybe I do it about 80% of the time. I'd like to be more than that, but reality is probably 80%. It's amazing how quickly you can forget how to run your own functions. So that's always handy. I'm not going to go into C also, but you could have that there. References, I find this really useful. So if my function, is referencing something else, could be a paper, could be some links, I put that in there so I don't have that kind of information kind of scattered across in my notebooks or notes or anything. All that information about the function, I'm going to have that in this file. Keeps it really organized. And lastly, it's important to have this at export. When you're starting, go ahead and put at export on every function. As you get farther along, you may start using like utility functions you don't want to show the user, but when you're starting, it's fine to export all of them. And then you have your function code there. What's a good resource to learn R oxygen? Yeah, that's a good question. So I put some references down at the bottom that may help. I think other people's workshop material actually I think is more helpful than the R documentation. I think the R oxygen documentation is way more complex than you need when you're starting, and it gets you more confused than anything else if you just go into all the details from the beginning. So, maybe try the workshop here. However, as I said, this template that I'm showing you, where is it, right? Yeah, that template right there, that's all you need for a long time. Once you need more than that, then you're going to be, real comfortable with it, and it'll be, like, going into the real documentation is going to be an easier entry. But just don't do anything more than this. And then when you feel like you need more, I warn you, you can waste a lot of time trying to customize your R oxygen headers so they look all like cool and nifty, and then you realize, wow, I could have done something simpler and not spend 2 days on trying to do a inset list or whatever. Okay. Okay, so now thanks, Ariana. Yeah, if anybody else has great references for R oxygen, please throw them in there. I put a few that I've used down at the bottom, but there are lots of others out there. Okay, so next we're going to go on and we're going to use PackageDown. So let's go back here. Okay. Oh, before I switch to PackageDown, I have a section here on adding references. I'm not going to go through that, but I have the instructions here. And if you do have a lot of references for your package, then following these instructions will save you a whole lot of time, because you don't have to like keep copying those citations. You're just going to have a citation file and insert those. A little bit of learning there, but if you have to deal with that problem, it will be helpful. Okay, so let's jump down to PackageDown, and I'll show you an example here. So here's an example of a PackageDown site. And so the people who made this, they didn't write, I mean, they did write this, but they didn't like write the HTML. This is all these function stuff here is all being generated from those R+Oxygen headers. You're not like, yeah, no, we don't write our own HTML anymore for this kind of stuff. Yeah, we just it's just going to take those R+Oxygen headers and it's going to create this for us. Those R+Oxygen headers are also used for other things, like if you've ever gone on to say CRAN and looked at the help file for a package, and they all have that standard format. It's a PDF, it's got a table of contents, and then it's got references for all the functions there. Do I have? Yeah, I think somewhere down here I've got some other examples, but you've seen these before. That, again, we're not writing that out ourselves. That's all built from those R+Oxygen headers. So using the standard documentation format, using the standards headers, really simplifies documentation and maintaining your documentation. Okay, so let's go ahead and make a PackageDown site for our website, so that we can make it easy for people to check it out and see all the function info. We are going to use two packages, use this and PackageDown. And I've already got those installed, but if you don't, just run that code. And then I need to run these two lines. You don't have to use this for this, but the use this package just simplifies things a lot. It has all kinds of really fantastic little helper functions. And it just kind of sets things up for you. It has a nice thing for doing packages too. So let's look at what it did. So here it set the active project. Okay, that looks okay. It wrote a PackageDown YAML. So it created this file for us. Okay, so that seems all right. Doesn't seem too bad. Tip for when you use this, you always want to look at what it did, because it's not uncommon to have to modify something. In this case, all it did was create this file here, so we can check that out. Kind of boring. Okay. So now let's do the second one. Let's do that. Got all this JavaScript, it's writing all that HTML, and there we go. So now you can see, and it just opened it up as a preview in a browser for me. That may be how I have it set up. You may have it pop out into your own window, but it creates this basic, this is the default template here, and this reference is using those R+Oxygen headers. And you can see I've got all my functions here. I can just click that, go back here. So now I have this nifty landing page. for it. Okay, let's go ahead and close that. So that that default is definitely a little bit it's kind of boring. It's very simple. If you know, oops. Yeah, if we look at this one, you see it's a bit more complex. This this formatting is a little bit different. Oh wow, look, it's got vignettes over here, and I see there's a question in the chat about that. And we can go here and see our little vignettes here. Vignettes are like long documentation. So this has a little bit different feel to it. And this is going to be set up in that package YAML. And you might also have extra CSS. And instead of like writing all that yourself, the way to go is to look at somebody else's template. For those of you in NOAA, the Fisheries Integrated Toolbox has a template that you can use. So you can just, go onto here, and it's going to have some extra bells and whistle for you. It's got some extra CSS. It shows you an example how to kind of change your add this nav bar at the top and change how it looks, all that good stuff. And this is the way to go if you're using PackageDown to figure out, like, how do I structure it to make it look the way I want it to look. You go to somebody else's PackageDown site and you look at their PackageDown YAML file and use that. Okay, so let's go back here. So there's a question about vignettes. And that's quite easy. Just click down here. I'll walk you through the instructions. I think the use this helper function is probably the easiest. And so you can just do use this. I think I didn't test this, so I don't know if this is totally going to work, but let's see what happens. So I have to put the name of my packet, I think. Well, is that right? Oh, I can't remember the syntax. I don't know if I need to say the name of. Let's see. Let's see what happens. What did it do? Okay, it added knitter because you need knitter for vignettes. Okay, it adds some things to my description file. That was good because I would never remember to do all these things. Adding in stock to git ignore. Okay. Creating vignettes folder. Okay, that's good. Okay, adding some more things to my git ignore. I'll have to decide later if I like that. Okay, adding that to the suggest. Okay, that's good. And now it's made this test vignette. Okay, well, that's nice. That was good, right? So you can see the utility of using the use this because I didn't have to remember all these steps that I need to do. So now let's go ahead and build my site and see what happens. Oh, look at that. It's building my vignettes. Nice. And now I've got articles. Aha. And now I have my vignettes listed here. And there we go. There's my test vignette. So if I wanted to edit that, I just go in here and start editing this. It's got the header I need, and then I can just add whatever code. So if you've ever worked with R packages in the past, you know that like setting up your vignettes and everything was a bit of a nightmare getting that right. And now that is really simple. It's simple with RStudio, simple with PackageDown, and using the use this really automates the whole process for you. Does CRAN support the license in the template? No, you have to replace that with a real license. So, yeah. Yeah, so Luke is talking about this right here. No, it will not. CRAN would not be happy with what license is it under. It wants a real one. Okay, so let's now share this package on GitHub. Well, let me talk actually first, back up a little bit, talk a little bit about how you would share your package. So kind of the three basic ways that you could do that. So you could just share a zip file, email that, or host it somewhere. And if you're in our studio, the way you're going to do that is click More, Build Source Package. There we go. I could build binary, but it wouldn't be very good for sharing because it would be building for the laptop that I happen to be on. So you'd have to be on an Apple with M1. But with the source package, anyone can use that. And so you can see it built this tar-gz. And where did it put it? I don't know where it put it though. Where did you add that? Back here? Modified? Oh yeah, there it go. Okay, it did it back above the package level. So there, that tar-gz, I could share that. That's one option. Okay, so I could put it on like CRAN or some other hosting site. Now, if you do that, CRAN has lots of checks that you have to pass. They want packages that are really, really robust, that work with other packages. So there's a lot of extra checks that you have to go through if you put it on CRAN. And then you can share it in the cloud. And I'm going to show you how you can just put it right up on GitHub and somebody could install that. So let's go to GitHub. Oh, yeah, here we go. Okay, so I'm on GitHub. Okay, so go back here. I am going to show you how to get it on GitHub, but I'm not going to be using Git and I'm not going to be pushing or up to it. So I want to kind of separate out these skills of learning how to get something on GitHub and setting it up to be able to view that PackageDown site. I want to separate that skill from the whole connecting your local computer to Git step. So I'll try to put a video just to show you how I would connect up this repo that I'm going to make on GitHub, how I would connect it to my local computer so I could just push changes, but that's not what I'm showing right now. So let's start off. We're going to make this new thing. I'm just going to call this test. Okay. And I'm going to add a README because I'm going to be adding files to this. I don't want that. I don't care about that. And so I'm going to create. Okay, there we go. So now I've got that. So now I want to go here and I want to get these things onto there. Again, like in my real life, I'd be using Git or GitHub Desktop and I'm pushing them, but let's see another way we could do it. We don't have to do it that way. We can just do it like this by adding them. There we go. Add that. Let's add some more. Add that. Okay. Add that. Okay. When I was testing this earlier, it was happier if I did it in pieces. Process. Okay, good. How do I know kind of what I want to be adding? So basically, I want to add anything that doesn't have a dot in front of it. So I'm not going to add any of this stuff right now. Get that description in there. Okay, I definitely want the docs if you look at what docs is, you see it's got all the HTML. If I'm going to be sharing my web page there, I definitely want the docs. So that's pretty critical. Okay. I think it's nice also seeing this file upload, because just to know that this is an option. Like if for some reason getting things synced up with Git on your local computer is not working for you that day, kind of, I mean, even if you use Git all the time, there can be situations where you're on somebody else's computer or something, or you're, you know, whatever, you're in a situation where you can't link up your computer. So I'm almost there. Need to make sure I've got everything. I haven't gotten my R. I got my namespace. Let's get this on here. And then we'll get our vignettes. Okay, I think that's everything. Commit. Okay. Okay, so let's make sure we got our whole package. What do we need for our package? It's a package. So we always need our description file. We need our namespace file. We need our R file. I had some data in there. And we need our man. And we created those vignettes. The docs is the thing that PackageDown created. And then we have this PackageDown YAML here. Okay, great. So that's our package. So now we could, if we wanted, just share this with someone. It's now in a state that somebody could install our package just from this. And how do they do that? Sorry, I didn't write the code down. I always have to look it up myself, which is what I'm going to do right now. Okay, so yeah. So this is the bit of code that we need to install it. So what I'll do is I always put this in my README, because as you can see, even though I do this all the time, I myself am forgetting how to install from GitHub. So I have DevTools here. Actually, I think Remotes is the one that's more common. If somebody there has that code handy, if they, I think it's the same syntax, but I'm not going to make it up. So yeah, test. There we go. So that's how I would do that. And like I said, I always put that in my READMEs because I forget it constantly. Commit. There we go. So that's what you would have to do. So somebody who wants to install your package or install this, now that it's on GitHub, all they need is this 2 pieces of code and they can install that. Super easy. So next thing, we are going to show how to make a nice, pretty landing page. We created that package site that we just saw. I showed it in my browser, but that was all local, right? This right here, you can see it says users Eli. That's local. Now, how do we get that so that I can just give somebody a link so they can explore this site? Well, it's easy. You're going to go to settings in your repo. You're going to go to pages. And this is what it's asking for, the source. So I need to tell it the branch. I only have one, main. And then where are those HTML files? I have the PackageDown is putting them in the docs folder. So that's what that is. Save. And you can see it gave me a link here. Now it says it's ready to be published. It's not on green yet, so it's not done. So you have to wait a little. I'm always impatient, and I used to just click on that all the time, and then but there's a better way. Um, you click up at this actions thing, and you can watch what it's doing. It's building and deploying, and you can see it's working. So you can just have this open and wait until it's done. Okay, so to look at the questions now. We'll just wait until this deploys. Yeah. Yeah. Yeah, Diana, I forget my syntax all the time, which is why I always or I try always to put examples in my help files. Otherwise, I'd constantly forget how to use my own functions. Same with my data. I always think, oh, I'll remember exactly how I created this data. And like the next week when I go on it, I've forgotten. So when I document my data, I put the instructions. Okay, hey, it's done. Excellent. Okay, what is the link to that? Well, fortunately, it's going to tell us. I can just click here and I see that. And there we go. So now I've created something that is super easy to share with other people. And they can read my fancy vignettes right here. So you can see how just creating this really makes a much easier entry for people, easier for them to use and understand your package. We don't have a download link here, but that is something that is super easy to add. So is it on here? Where is this? Well, it's not on this one. But if you look at other PackageDown sites, you'll see they'll typically have a oh, here it is. Sorry, source code. It's just I'm used to it being over in this corner. And this PackageDown site put it right here. So they put a nice link. So even if you go here, the person can click here and they can go back to your GitHub repository and see the source code. Thank you, Catherine. Yes, they have remote install GitHub. So looks like it's very similar to the syntax. Everything's gotten slow all of a sudden. Come on. Why are you doing that? Okay. Okay, I fear I may have. Okay, I'm back. Okay, hopefully I didn't glitch out there for a moment. There we go. Okay, yeah. Yes. Okay. So Catherine put in the syntax for the remotes. It's the same syntax. Okay. Last few tips here. One, styling your code. So having code that has a consistent style makes it easier to understand, cleaner, and you don't have to remember to do that and worry about it. There's a little add-in package for RStudio that uses this R package called Styler. You just install that package and then you can say style and it'll style whatever you want, either your open file or it'll style your whole package for you. So clean up all your code. So that's great. Same with spell checking. The RStudio has an add-in for that. I think the one I use is in the use this package. So I'm writing really long things with like reams and reams of documentation. So I like have a whole like personal dictionary and everything for all my weird jargon stuff. And I'm pretty sure I'm using the use this package. Anyhow, it's automated. Okay, the last thing I just want to show you, just got a couple minutes here, is checking your package. So when we go over here, so here's what I'm on my package here, and you see the build, I see the check here. So I'm going to go ahead and I'm going to make this bigger. Let's run this check. Okay. Okay. Warning. Okay. What? And so check is really verbose, but it's actually really helpful, and you should try to get rid of all the warnings. They're it'll warn you about things that are really like small, but fixing those does make your package more robust. So okay, so here, so something in here, it's saying it's depending on R greater than 3.5. So it wants me to have this in here. So what it's telling me is that there's something about my code that actually it wouldn't work in a really, really old version of R. Like really, hopefully nobody would have something that old, but maybe they would. So let's go imports. So what it's wanting, I wish it had better instructions, but this is what it wants. It wants that right there. Okay. So you see here, I'm saying it depends on R, and R needs to be greater than 3.5. This way, if somebody tries to use it and they had an older version of R, it would complain. This is really going to be helpful for those of you who are using functions that depend on R for something. There have been some changes in R. So last week we talked about the new base pipe. That's a good example where you're going to want to have R greater than 4. Whatever, whenever they introduce that base pipe. Otherwise, they won't be able to run your package, and they'll have literally no idea why. It'll be just a mystery. So if you do have dependencies, you want to specify them here. You'll help people out. Okay. Yeah, it's saying it's happening because of the data file. That's okay. There's nothing wrong there. I just need to add that dependency. Checking package dependencies. Depends entry. Namespace dependency missing. Oh, okay. Okay. Missing. Okay. So again, it's saying it's an error. Oh, goodness. Okay. So now you've got an error. So this is a real world example. And this shows you exactly the sort of thing you're going to have. So the package built fine, it runs fine. I could totally share this. That thing that it's complaining about, it's obviously not interfering with using it, at least from my perspective. It's not interfering with it. And I say from my perspective because I have dplyr installed. I have mgritter installed. What it's complaining about is that, hey, the way you've set up your package, if somebody didn't have this installed, it could cause them some problems. So that's kind of what's going on there. So the way you're going to deal with that is, I thought I had it import from. I don't know why. Well, I'd have to see. I thought it was there, but somehow it is. Oh, that's what it is. Oh, okay. Yeah. Yeah, see, Diana, this is real world. This is exactly how you debug your checks. You're like, what are you complaining about? How do I interpret that error message? So it's saying it's missing from my description. So what it wants it wants this here. So it wants every package that your package uses, it wants you to list them in description, because when somebody tries to install your package, it's going to be looking at that description file to determine what it needs to install, what it needs to work, and it wants it all there. So it's warning you about that. That's a good warning. Okay, let's try it again. Okay, that's all good. Let's see if I can pass check. And all good. Okay. Well, we got farther. Now we have some warnings and some notes. Okay, so now it's warning about no visible bindings for global variables. So there's something in there. Again, package is going to work, great. What you're seeing right now is exactly what you're going to run into when you start using check. And here I just used like the default package, but when you use check, it's going to be really picky. It's trying to help you make a really robust package. And on here, checking your package, I'm going to give you some tips for how you need to solve those things. And another tip is when you start trying to pass check, sit down with somebody who develops packages so they can help you walk through that the first time and write lots and lots of notes for how you solved these check problems. Now, the last thing I see, it's 11:02, is the last comment about check. Lots of packages you see on GitHub do not pass check. And you'll see the badges where it says if it's passing our command check, and a lot of them say failing. It's not that there's anything really wrong with the package. It's just not quite so, like all the I's are dotted, T's are crossed to the perfection to pass this kind of stringent check. So it is good to pass it. It makes your packages better. And then my tip is to run check early. Don't leave it towards the end. Oh my goodness, keep running check as you're developing, because if you leave it way towards the end, you just have so many warnings to wade through that it's really hard. Okay, I'm going to stop there